Good morning, everyone. My name is Bob Pothier. I am the Senior Technical Manager at Uila. It is pronounced Uila, W-E-E-L-A-H, even though it's spelled U-I-L-A. So just so you have an idea, it is actually a Hawaiian word for lightning in the cloud. So if you happen to get an email from us and you saw the little lightning in the cloud, little icon or the little movable picture there, that's why you got that, and that's what that means. So we wanted to make sure we explain that. So just so everybody has an idea, I have been involved with VMware for several years, probably close to 10 years now, and very excited to be talking to you today about virtualized environments, virtualized applications. And obviously, things have changed quite a bit over the last several years with the advent of hyperconvergence and things like that. The data center has become extremely virtualized, and we know that by 2016 that 86% of our servers will all be virtualized. So we started with the low-hanging fruit. We started with those print servers and maybe some small file servers, things like that. And now we're starting to see that we need to virtualize those tier 1 applications. Again, with software-defined data center, software-defined storage, software-defined networking, virtualization has become extremely powerful. And not only with the hardware, but also the software becoming much more mature. And again, with hyperconvergence making its play, now we want to start seeing those virtualizing more and more. But we needed to make sure we got to the point where we knew that we were able to run those applications comfortably. It also creates complexity when you start to virtualize. Certainly there are certain issues when it comes to virtualization, uncorrelated data that doesn't get shared between environments or between teams. East-west traffic causes blind spots. If you're looking at the networking and you're looking at certain east-west traffic versus up and down the stack, we're not able to see some of those things. And of course, we have organizational silos where you have app teams and you have infrastructure teams where the application owners only have some certain visibility into the environment, and the infrastructure team, the data center management team, they have their tools and they can see their environment, but they're not really focused on the applications themselves, which of course is very, very important to the organization. So making sure that those applications are up and running at peak efficiency 100% of the time. So we have those silos with tools as well. And again, application owners have their tools, whether it's for specific database, SAP, PeopleSoft, that sort of thing. But that gives them some kind of, they lose focus when it starts to go back towards the infrastructure. And then on the infrastructure side, the data center manager, they have their tools, in order to monitor the VMware or maybe monitor certain storage. But they don't have that visibility into. But as they start to work into the correlation into the infrastructure, whether that's the virtual infrastructure or even down into the physical infrastructure, they completely lose their focus and they don't have that ability to see that. And then of course on the infrastructure team, they have the ability to see the physical infrastructure that they own, that they manage. They have the virtual infrastructure, so they see what's going on inside of VMware, and they sort of have some idea of some applications that are on there, but they're not really focused on that. It's not that they don't care, it's just they don't really focus in on individual applications unless it's a smaller company where you're a jack of all trades and you not only are the infrastructure management team, you also own the applications and you manage the applications as well. So there's this gap right there in the middle where we want to make sure we have that correlation of the application to the infrastructure. So we want to eliminate some of that finger pointing that goes on between the infrastructure team and the application team. Of course, that becomes time consuming when you try to start figuring out, well, I know my application is doing this, but I'm not seeing what's going on in the application. So they get in there and they start doing what they need to do with the infrastructure, and it may cause issues with the applications, and they don't even realize it, or you don't even realize it if you're on the data center team. And so the problem is we have this lack of visibility there, and so we're not really sure we want to to virtualize everything because we're not sure if we're going to be able to see it or not. And if we do virtualize it, can we optimize that and make sure that it's running at peak efficiency? And so those are some of the pieces that are missing with the common tools that you have today. So what we want to do is we want to regain that visibility. We want to make sure that we can see everything on the left-hand side, the applications, as well as the virtual infrastructure, as well as that physical infrastructure on the right-hand side. And that's kind of where we come in. So it's a management tool, nor is it an infrastructure performance management tool, because sometimes you have those tools. What we want to do is we want to give you the ability to correlate the two. Have the application virtualized. We want to make sure that it's running at peak efficiency, but we want to make sure that the infrastructure that's being provided for that application is also running at peak efficiency. So what we want to do is we want to do three things. Number one is we want to visualize. That's one of the key things that we find as we talk to people when we start talking about our tools. They say, hey, I don't have visibility. I have no idea what's going on because my tool has its limitations to go to a certain point, and then I don't go any further. So we want to visualize that and be able to see the application and the infrastructure all in one dashboard, all in one window, so that we can see exactly what's going on between them. We want to be able to analyze that and now be able to create root cause scenario where we can go in there and say, hey, I see that this particular application is faulting, it is suffering from some sort of issue. I want to be able to click on it one time, boom, there's my root cause. And that's exactly what we want to be able to provide. And then we want to optimize it so that we can make sure that we clear up any of those bottlenecks, that we make sure that we're going to have the best application performance moving forward so that we don't have to go back and try to find root cause all the time. We want to resolve those ahead of time so that we can optimize those applications. So imagine if you were able to empower the infrastructure team to be able to do a few things. As I mentioned, isolate root cause, whether that's a single tier or a multi-tier application. So if you have a web front end with a database, things like that, multi-tier applications, we want to make sure that we can visualize, analyze, and optimize those. What if we can identify application starvation due to things like CPU over-provisioning? So we have too many CPUs assigned, so therefore we run into CPU ready issues. We want to be able to pinpoint that immediately. We wanted to be able to track network latency factors with those critical applications to make sure that we're not efficiency, and I've got some use cases that I want to talk about as we step through this. And then of course measure, and the key word here, prevent virtual application downtime. We want to make sure that we don't have any of that. So imagine if I was able to make this phone call and I said, hey Steve, it's Bob from IT operations. I believe we can improve a certain application, and he really doesn't realize that his application is suffering. It may have just been slowly going down and slowly getting worse, and he doesn't really see it or feel it, but he's about to. So we want to prevent that and be able to see that ahead of time. So let's talk a little bit about the Uila architecture. I'm going to go ahead and draw this screen out here. So this is our Uila architecture. So you'll see here we have three components in blue. At the very top there we have our main management server. We call it the UMAS, the Uila Management Application Server. So that's sitting at the very top here. That's going to be a Hadoop database, as well as all of that can be just a simple VM that we deploy inside your infrastructure, or we have it already built in our cloud, so you can just use our cloud instead. Right below that, in the middle there, is our Uila Virtual Info Manager, and what that does is that collects the data from the right hand side, which is our virtualization management tool, so i.e. vCenter. So that's going to give us our compute, our CPU memory, storage, some networking capability to be able to see what's going on that side, collect all that data, send it up to either the cloud or to your on-prem management server, and start doing some analytics there. On the other side, we have what we call our virtual smart taps. So the virtual smart tap is a small VM. It's like 1 CPU, 1 gig of memory, 1 gig hard drive. And what that does is it sits on your host and it monitors all the traffic on that vSwitch. So if you have a couple hosts, they each have one vSwitch, you're going to have a couple of these little VMs that are going to collect the traffic. It sits on that vSwitch running in promiscuous mode, so it sees all the different VLANs inside your DMZ, all that kind of stuff. We're going to be able to gather that metadata. We're going to pass that through the info manager up to that Hadoop database. So we don't really hold anything inside the Smart Tap. We don't really hold anything inside the Information Manager either. We're basically pushing all that metadata up to that Hadoop database. And again, we'll talk a little bit more about security as we go on, but there's really no personal information or anything that's being sent either to our cloud or even staying internally, because all we're doing is really grabbing information about applications, the server names, response times, things like that. We're not really talking to anything specifically about what information is inside of that packet. Okay, so let's jump over to our live demo. This is a web UI on the infrastructure page there, or the architecture page that I was just showing. The Hadoop database, the analytics, all is provided inside that either the cloud or on site, and then we just have a web UI that we can get access to that. I'm looking at our cloud here for our internal lab. And the first thing we see here is our dashboard. So it is an interactive dashboard. I can move things around, I can play with things, but let's take a quick look here at each one of the sections, and then we'll start to drill down into some of the capabilities. So the very first thing you see here at the top is our time matrix. So think of this as kind of your application and infrastructure DVR. So we're able to see what was going on when. We have the ability, because all of these data points were put into that Hadoop database, we're able to keep that information forever, basically, as long as you want to keep growing the size of that database. We're able to keep all the information, so if I wanted to go back and look at the way something was performing from 4 o'clock until 4:15 p.m. on June 12th, I have that capability. Okay, so we don't have to worry about doing little specific roll-ups and things like that where we lose that granular capability. We actually still have that capability. You'll notice that this window that we see here at the top is actually a 24-hour window. Okay, it's when by default it's a 24-hour window. You'll also see that I have a little shaded area right here. That shaded area is actually a 1-hour window. Everything that I see below in the bottom 80% or so percent of my screen is related to that little shaded window. So if I decide that I want to expand this window out this way so that now I'm looking at, say, 3 hours, everything down below is going to change the way it looks. Okay, so let's take a look at the abilities that we have below. So we have down here many different what we call widgets. You have our application performance, we have our network health, CPU health, memory health, and storage health, as well as application server alarms. So if we go up here, and you notice I have this shaded window, I'm actually going to move this back over to about a 1-hour window, and then I'm going to zoom in. I'm going to press this zoom in button so we can get down a little bit closer. So hopefully you can see these little white lines that are in here. So I have multiple columns. Each one of these columns is a 1-minute block. So that's the column. The rows have to do with application performance on the top row, CPU health on the second row, then memory health, storage health, and network health. So if I'm looking at this, I can already tell that memory is probably my biggest problem, which I can look down here and see there's a bunch of red down here as well. I can also see storage has some issues. So we have several different ways that we can attack these different colors, and we typically want to hashtag follow the red, right? We're gonna start using that all the time. Follow the red. Find those red issues where something is in a red condition, and go figure out what it is that's having the issue. Find out why there's an issue and get it resolved so we can turn it back to green. So we can do that several different ways. If I wanted to, I could start with going down to the memory section, because I know I have red in memory. I have red in storage, so I could go down to this storage health. So for example, if I open this up and make it bigger, I can now see everything a little bit easier. You'll notice that I have VMs on or actually virtual disks when it comes to storage. We have virtual disks on the outside. We have our hosts, we have our data stores, and then we have our data center. So I can see here that data store 1 in parentheses 4 is definitely having some issues. That is related to host number 4, and then these are the disks that are associated to that, or the VMs that have virtual disks on there. So if we wanted to start that way, we could. The way I like to start is by going to our server alarms. This tells me exactly what I want to see as quickly as I need to see it. So during this 1 hour window, and I'm looking at 5 a.m. to 6 a.m. this morning, I can see that I have 3 application alarms. Now, this is brand new in the current version, is we have 2 different sections to our severity here. You'll notice on the left hand side I have a big red box or a big orange box. I can have a big yellow box. Those are giving us our severities. If I go over here to quick help and I click on that, it'll actually tell me what those are for. So critical being red means alarm 50 to 74, and then normal is green. Okay, so what we see here is we see that our application health score, and that's a combination of response time. It takes into account best practices from VMware and Microsoft and others to be able to build up these baselines that gives us this main criticality. So is it a critical, is it major, is it minor, or is it normal? So it shows this very first one as red. These 2 are both orange. And right next to that you'll see there are additional little boxes. So you'll see that it looks like 1, but there's actually 2 green boxes here. This is CPU. If I move over, this is memory. This is storage, that's red. And then gray, which is a dependent service. Maybe there's an additional service that that this application relies on that actually has an issue. So for example, this one down here, I can actually see that I have a yellow alarm for storage, but I actually have a red alarm for some dependent service. So this one up here, I know that it is storage and it is in red, so I'm going to go ahead and click on that, and we're going to get to the root cause of this application performance issue. So what I'm looking at here is MySQL. You can see it right up here at the top, MySQL application response time for Oracle 11g N1. So MySQL, the response time is about 600 milliseconds. That's very slow. That is definitely too slow for my comfort. Now granted, it is just one little box here. Of course, we'd want to probably look at this on a longer scale. See, does this happen every day? Does it happen for longer periods of time during certain days? Things like that. So we want to take a look at that. But for this particular window, this 30-minute window, I can see that CPU, absolutely fine. Memory, absolutely fine. But my storage is showing that it's a 97% likelihood or probability that storage is the root cause of this problem. And if I look at that a little bit closer, it says that it actually has to do with read latency. So I'm going to click on this little circle here, actually anywhere in this red window, and I'm going to get more information about that particular storage. So what we see here, and when I scroll down just a tiny bit, is I can see my VM, I can see my host, and 183 milliseconds. That's really high. My application response time over this given period of 15 minutes, because that's what or 30 minutes is what I'm looking at, is about 264. So certainly higher than I expect. Write latency seems to be fine. My IOPS is actually pretty good, both read and write. If I go down to my host, I can see that my host is actually fine. My latency on my host is fine. If I go down to my data store, I can see that my data store latency is actually okay too. It's only 121 milliseconds. Now, sometimes what we'll see is we'll see a high latency both on the VM and the host. And so what I would want to do is I would want to click on this host, and it would actually show me which VMs are on there and how their latency is or what their latency looks like. So this one particular host during this period of time shows that Oracle 11g N1, which is the one I've clicked on, is extremely high compared to everything else. But sometimes you would see, maybe we were looking at, say, MySQL N1. If we were looking at MySQL N1 and we realized that we were having an issue as far as our application response, maybe it's a victim of being on the same data store or on the same host as Oracle 11g N1 because its latency is so high. So sometimes it's a problem and sometimes it's a victim. Ops again down here on the data store and on the host are pretty good. I'm not too concerned about that. So really I think it's this VM, and it may just be the this particular point in time. So again, we can go and we can look at a longer length of time on one of our other windows, and we'll take a look at that monitor here in just a moment. So that's step one. We want to find the root cause of an issue very, very quickly. So typically we're going to see things in one of those areas: CPU, memory, storage, networking, or sometimes we just find that, hey, look, the application is performing poorly, but the infrastructure is absolutely fine. So then we might have a problem with the application. We can go and we can talk to SAP, we can talk to PeopleSoft or Oracle or Microsoft and say, what's going on with this application, and be able to find those particular issues. Now, one scenario that I wanted to bring up just happened the other day is we had an issue with a customer having high latency response times with their on their network for Exchange. So they went and they dug around a little bit, and they ended up finding out that on their UCS chassis they had 3 uplinks that were not working, completely not working, and they had no idea until they were using our tool. So they were able to find that within a couple days of putting the tool into place and starting to look, and they've had plenty of other tools in place for a while that none of them had showed them that sort of issue. So they had Cisco coming out to help resolve that issue, but they literally had no idea. So it was a pretty cool scenario that somebody was able to find very, very quickly. So again, this is our dashboard. It is real time. If I click on real time up here at the top, it will go to a real time 24-hour window with the last hour, the last rolling hour, basically, as my time window that I'm going to be looking at. But again, everything that I look at down here in this bottom 80% has to do with the time window that I've selected. So I'm going to leave it selected on this time because I see several different issues here. So I want to kind of stick with that. And I'm going to go over here to the left-hand side. So what you see on the left-hand side in our little, I don't know, tabs, I guess is what they would be called, or links, we have the dashboard, which is again that real-time, always running. You can very quickly at a glance get a view of what's going on. And then we also have monitors that go along with each one of those. So application topology goes along with application performance. Network analysis goes with the network health. CPU, memory, storage, and then we also have a stats browser, which we'll take a look at here in just a second. So let's click on application topology. And what application topology is going to allow me to do is actually see how everything in my infrastructure is talking to each other. Okay, so I'm going to zoom out a little bit. So I've got some little windows over here. Probably need to just redraw this. There we go. So now what this does, it allows me to see, okay, this particular VM is talking to these VMs. Oops. And if I wanted to, I could then click on that one particular VM. I see that I have HTTP as a service, also known as a classifier for us, and an application. Those 3 words are synonymous for us. And you can see my response time is about 1. So when I click on that, what it does is it shows me all of the dependent services that particular server leverages. So this particular server, WebLogic 11GS2, relies on Walmart Test N5 for SSH. It relies on DBLB002 for MySQL. It relies on Oracle 11G N3 for SSH, MySQL, SPDY, TCP, which then relies on this one for Postgres, etc. So this gives me that ability to visually see who's talking to who or whom. I always get that wrong. So this is a very graphical way of seeing who's talking to who, and then I can start to drill down from there. So if I know that I have a red condition or an orange condition here and I want to click on this, I will then of course go to my root cause page, which is exactly what we want to be able to do with applications. This one shows one single spike right here. It actually shows that it's possible that it's a CPU issue. If I click on that, it'll take me to my CPU and I can look at that. Looks like my CPU ready is actually a little high. So again, we talked about this at the very beginning. CPU ready basically means that I have too many vCPUs attached to that or provisioned for that VM, and it's having to wait for those CPUs to get filled up so that it can actually do its action, process its ounce back. So that's our ability to see our application topology. So we also have this network analysis window. So this gives us the ability to see everything from the host to the switch, to the actually vSwitch, to the port group, the VM, and then down to the classifier. Again, classifier, aka service, aka application. So what you can see here is ESX host number 5 has, it's connected to this DV switch 2. It has a port group, and then it has several VMs, and those VMs are providing these particular services. So, as I mentioned earlier, we want to follow the red or maybe the orange in this case. So if I want to go down and look at this one particular application, I can see which VMs have that particular application. So if I'm looking at SPDY, for example, I can see that Oracle 11G N2, N3, and N4 all provide that particular service. I can see what my response time is, my application response time is for each one of those. So I can see all of this in one single place, as opposed to having to go look at each particular server and try to figure that out. Again, with common tools, you're going to be looking at a specific VM and trying to figure out what's going on, when it could in fact be another server that's causing an issue with that VM and making it a victim as opposed to being the actual problem. One other thing that we do have the ability to do, as you've noticed, I have been talking a lot about VMware. We are pretty VMware centric at this point. With regards to virtualization anyway, we do have the ability to see physical servers, physical gateways, things like that as well, which is introduced about 2 versions ago. And we also have the ability to go one layer up when it comes to networking as well, by going to the top of rack switch. So if I use my scroll on my mouse here, there we go, then I can actually scroll and get that kind of shrunk down. That's probably a word. Shrink that down. Now we can see that I have a top of rack switch. It's actually labeled undefined. Some switches are labeled very well. Sometimes they're not. This one particular one is not defined at this point. It doesn't have a name, but we do see that my 5 hosts are all talking to that. So the important part about this is we talk a lot about the vSwitch, and we want to see how things are going in and out of vSwitches, and that's what those virtual smart taps are for. The virtual smart taps see the information that are coming in and out of that particular vSwitch, but what happens when it goes outside of that host? Right? Because VMs don't always just talk to the VMs that are inside of another host, inside the same host. Sometimes they cross over, so we want to be able to look at the top of rack switch and be able to see what's happening once that information, those packets leave that one host and go to another host. We want to make sure we don't lose that visibility when it jumps across. So we have that capability as well. Inside the settings, we just use SNMP. We attach to that particular top of rack switch, and we can start monitoring that as well. So moving down to the next one, we also have CPU analysis. We have several different ways of seeing CPU and memory. You'll see that we have similar options here. We have circle packing, which basically says, okay, here's my my data center or my cluster. My data center. Here's my cluster. Here's the individual host. Here's the individual VM. So we can see there's a different size as far as the amount of action, CPU action that's happening, or CPU usage, as well as the color showing us our response time. And out one of our specific hosts, you click expand. Actually, I think I just hit filter. Sorry. So I filtered. Let me open that back up. Expand that out. There we go. So now once I open that up, now I can see each individual each VM, and then I can, so here we go. Here's port group and then our VMs. And we can see they're all green, which is great, but certainly if they're yellow or orange, we'd be able to go to that, see the application, click on it, and go straight to the root cause. Again, that's our main idea here, is to be able to get to the root cause very quickly. We also have the table format for those of you who just like being able to look at a quick table. Of course, we want to follow the red. We want to look at that. We find that Walmart test N5. We click on it. Now we can click on SSH, go to the root cause. Boom. We can find out exactly what's going on. My guess is it has to do with CPU, or else it wouldn't be read under the CPU. We also have CPU alarms. So this will show us every alarm that's come. So it gives us a very quick at-a-glance view of all the alarms. And again, you can sort by any one of these these columns up here. So if you want to search by, or if you want to sort by service, HTTP or TCP, something like that, you can do that. You can also look right here at the stat, which is our CPU percentage, and our baseline. So again, our baseline is a couple different ways we can do baselines. Typically, it's it's based off of the last hour. You can also do over the last day or the week. You have some customization there. And again, it not only is just based off of the last hour, the last day, but it's also based off of best practices from VMware, Microsoft, etc. So we want to make sure we bring in those things. Memory looks exactly the same. So you have circle packing, the tree, and the table for memory as well. Now going down into storage, near and dear to a lot of people's hearts. I mean, when you're in the data center and you're talking about VMware, so often you're talking about networking and storage. It's just something that comes up all the time. So we don't want to blame the storage admin for everything. We don't want to blame the network admin for everything. But when you look at the chart and you see a lot of red here and there, you want to figure out why. And you want to get to the root cause of that very, very quickly, so we can go and talk to those admins and say, hey, this is what we think is the problem. This is what the tool is telling us. Here's the data that's backing it up. So when we go and we look at this storage flow, I'm going to again use my scroll mouse here. Scroll that down so we can see everything. So on the left hand side we have our data stores. On the right next to that we have our hosts, then we have our VMs, then we have our actual virtual disks on the right hand side. So again, following the red, I'm going to zoom in a little bit so we can see it a little easier. I see a couple red here. I've got my red lines going back to, say, for Exchange or our Zimbra. If I scroll down here, I've got Oracle 11g N1, I've got MySQL N1. So what I'm seeing is I see that my read and write latency for this particular disk for that VM, 350 milliseconds on a read. That's pretty high, especially if I'm only doing 40 reads per second. Then that's pretty low, that's pretty low, and the latency is pretty high. So we might have a problem with this application, or one of the applications on this particular VM. We may actually have issues with the host. If I go back to my host, I can look at that. I can see what my health score is of all my VMs that are on that. I can see my read and write latencies of each one of those VMs that are on there. So it looks like the VM I was just looking at, the Oracle 11g N1, had the highest. But I can also see that my N2 also has pretty high read latency as well. So that means I'm probably going to want to go back here to my data store and look at my data store, and I can see that on average I'm running about 144 milliseconds. So probably a little high. I think the industry would tell us that anything above 50 milliseconds is probably something we want to look at. So we certainly want to go figure out why that is that is happening. So if we go one step higher than that, we've spent the last thing on this VM or HTTP that's running on this particular server. But sometimes we want to be able to just step back and we want to see what was going on over an extended period of time. Applications that could all be impacted by that. So when we look at our stats browser and we look at this past hour, we can see that we did only have one alarm for this particular VM. So we can choose which VM, we can choose a specific host or a cluster, a VApp, whatever it is that we want to look at. I just happened to choose one of these. Let's see, let's go up here to Oracle 11g N1 because we've seen that show up several times as red. So again, here's our storage as red. If I go to my application response time, now we can see my response time for all of the services that is providing. Not just one at a time like we would see if we were to go click on it and go to root cause, because well, that's only one application. So this gives us the ability to see all of the applications that are running on that particular server over that period of time, that 1 hour. And you can see my response time for HTTP, 424. My response time for Postgres, 2.3 seconds. MySQL, 2.1 seconds. It doesn't seem like it's one particular application that's have as a high as of about 600 milliseconds during this period of time. And again, that's combining everything and averaging everything out. So that gives me about 600 milliseconds. If I'm looking at my CPU, things look good. If I look at my memory, things look good. Don't be too alarmed here. This is memory consumed. That's absolutely fine. That doesn't have to do with memory usage. So memory usage is what we want to pay attention to. Memory consumed is just basically provisioned. And then we go to storage, and that's where we find our issue. So again, we see that our issue here is about 780 milliseconds, so almost a second. Read latency, my write latency, absolutely fine. It's actually just under 50 milliseconds like we talked about a second ago. And then my total latency, which is a combination and average of the two, gives me about 400 milliseconds. So I think we're doing okay, but we might want to keep an eye on this particular one. And we also have the ability to zoom out and look at this for a longer length of time. So for example, if I wanted to look at, say, yesterday at 5 a.m. through today at 5 a.m. or 6 a.m. and click apply, it's going to change this. So again, just the way it was an hour ago or for the last hour, and then looking at it for a 24-hour period. So there you go. So you can see that for a long period of time we didn't have anything going on. Then all of a sudden it went through the roof for this period of time right here. When whatever was happening certainly jumped through the roof on all of that stuff. Okay, so I'm going to jump back to dashboard here. So we've looked at the dashboard. We've talked about how the DVR would work. We've looked at our dashboard as far as our widgets are concerned, real time. We have the ability to go to those individual monitors. And of course, the last piece is our reporting capabilities. So when I go to my reporting capability, you see I have a new report button and I have a scheduled report button. So I can configure a report to run, let's say, every Friday at 4 p.m. or every Monday at 6 a.m. and have it emailed to me so I can see what's going on. I have two different types of reports. I have a resource usage report, which is right here, and I also have an application performance report. So we're talking about application response time. Now I did go ahead and run both of these so that way we can take a look at them. The first one we'll look at our resource usage report for a specific cluster. So I'm looking at the HA cluster. There are 37 VMs in there. This is possibly what you might want to consider an executive report, a CIO report, where they would just want to see how things are performing overall. So you'll see here I've got a bunch of green dots. Oops. Maybe I don't. I have a red dot and a yellow dot here for this particular VM, so maybe we want to take a look at that particular virtual machine. I also have these pie charts here. If I scroll down, come on. If I scroll down a little bit, yeah, I went too far. So here's my CPU report, or my CPU pie chart right here at the top that shows me my usage, my top 10 CPU usage VMs. My top 10 memory usage by VM, as well as my storage, and then my network. And by network, we're talking about dropped packets, which we didn't see during this particular demo, which is a good thing because we don't want to see virtual packet drops, but we certainly could. And then we can get down into each one of these particular VMs. So I'm going to skip on down. This is the one right here. So CPU, you can see my CPU ready time is over here on the right hand side. In red, my CPU usage is in blue. So my CPU usage seems to be fine. My CPU ready is certainly elevated. We want to make sure we pay attention to that. You'll see my storage IOPS actually are doing just fine. I wouldn't be too concerned about this because my read IOPS over here in blue is only going up to about 75, and at the latency, both for our storage latency here, my read latency, write latency, actually still pretty good, and then my network traffic, my network usage, kind of high at the beginning, and then we have some spikes, and then we have our dropped packets, which is 0, which of course is a very good thing. The other report that we have, if I go to here, is my application performance, current fiscal quarter. So I'm looking at July 1st through today. I can see my response time, my average response time, actually has come down. It may be a little difficult to see, but I have my red line here as far as my average. It starts about right here, and it actually ends up even lower. So maybe we've used the tool to fix some things, and we've actually gotten our response time to be a little bit lower, which is awesome. You'll see that my CPU trending is actually going up just a slight bit. We've gone from, I don't know, probably about 17 up to about 21%. So certainly we see some usage increasing there. First, find out which VMs those are. See if there's some correlation there between the application and the CPU usage. Same thing with memory trending. Looks like that seems to be okay because we're not really going too high. And then we also have our correlation. So what we see here is when our CPU usage gets higher, what happens to our application response time? So again, if I'm looking at this, I see that my CPU usage is getting higher, going from say 5% up to about 55%. My application response time is still hovering right around 100 milliseconds or less, which is fantastic. So again, if we wanted to focus on anything, I would focus on some of these outliers that are higher and see if we can find out what it is that was going on with those particular VMs or those particular applications. Same thing with memory. I've got a couple little outliers here. So once we get up to a certain point of memory usage, we see a couple tiny spikes there we might want to look at. And then the same thing with storage IOPS. Once my storage IOPS get higher, does that mean that my application response time gets longer? And it actually appears that it's not the case. We had a couple little stragglers here at the very beginning when the storage IOPS were very low. So probably not an issue, but we probably want to go drill down, look a little bit closer, and see if we could find out what issue that was. And then below that, you actually see all the data that makes up the charts that we've just seen. All right, so let me go back over here. So what's next? We'd love for you to try out the software. Obviously, what you've seen here today is my lab. We make things happen so that we can see colors. If everything was green, you wouldn't think it worked, right? So we have to make some things happen. We have to make some colors show up. So we certainly want you to test this out in your environment. We do have a free trial that we'd love for you to download and try. Again, you don't have to worry about installing a whole bunch of stuff on your own environment. You can use our cloud. So basically you would just download one little OVA, deploy that. It's either, depending on how many VMs you have, it's either 1 CPU and 2 gig of memory, or 2 CPU, 4 gig of memory, and then a couple of the little smart taps, and off you go. So if you wanted to download that trial, head over to Uila.com and see our brand new website that we just came out with. You'll notice that there's a big free trial button right up the upper right hand corner. Click on that and you can certainly do that. You can also get more details if you wanted to reach out to us and get an individual demo for your company, where we can do this pretty much the same thing I did today and then answer a lot more questions. If you wanted to do that, we can certainly do that. You can follow us on Twitter. We have a YouTube channel called UilaTube that you can go out and see little 2-minute videos on how to actually use the tool. And then of course you can follow us on LinkedIn as well. So let's summarize. What did we learn today? Uila's Applicationaware infrastructure performance management allows the data center manager the ability to see applications and reduce the outages and downtime and performance impact of infrastructure issues, or to be able to exonerate a part of the infrastructure. So again, sometimes the application owner wants to say, oh, it must be the storage, it must be the networking. This gives us the ability to exonerate the storage and say it is absolutely not the storage, it is X. So we want to be able to do that, and we want to be able to do it very, very quickly. We also want to prevent issues that might arise by over provisioning, by applications that may need additional resources, etc. And we want to be able to tune those applications and tune the infrastructure for those business critical applications. So we certainly want to take that into account. And finally, we want to do this all without any sort of agents. We want to be able to do this very quickly. One OVA for the data collector, a couple VSTs or smart taps to be able to collect the information going across the network, and that's it. So we can do this very, very quickly and easily.